Hello, my name is Jeff Dusk. I'm part of the CloudBees core team, and what we're going to do is go over Kubernetes 101. This will be a quick introduction to Kubernetes at a high level, and then we'll also have a quick demo going over some of the basic concepts that we're going to cover in this presentation. So whenever I'm looking at a new technology, one of the things I like to find out is, what is Kubernetes? And so the quickest way to find out what the official definition is to go back to the Kubernetes website. Now, their definition is Kubernetes is a portable, extensible, open source platform for managing containerized workloads and services that facilitates both declarative configuration and automation. It has a large and rapid growing ecosystem. Kubernetes service support and tools are widely available. Wow, that's a big mouthful. What we care about are the things that are highlighted. Portable and extendable, that it manages containerized workloads. What it means basically, it's managing containers for us. And then one of the big things is it's like a declarative configuration and automation. So what does that mean? So the portable and extendable means that it runs on any of the clouds. And then the declarative configuration and automation means that we're going to have something that's going to help us out by being declarative instead of iterative. I don't have to do all the steps. So let's go to the next step. Once I have something that I know what it is, I want to know why do I care about it. And there are three big things here for developers we care about. And we're going to break them down. First, it was designed by developers for developers. Kubernetes was created based off of work in Google, because Google for the last 10 years or so has been managing their own systems with containers. And so they had their own thing called Borg, and this is based on next generation of Borg. It uses declarative metadata in the form of a YAML file. Now what that means as a developer, I tell Kubernetes what I want, but I don't need to tell it the low-level details. So I don't care how it does it, just do it. If you've ever done SQL, for example, when I go out and look for an employee in the employees tables, I do select star from employee where employee's last name is Smith. I'm going to find all the Smiths. I don't change that query if I have 10 employees or if I have 10 million employees. It's going to be the same query. And what's going to happen is what they call the optimizer will figure that out. And that's the same idea we have here. Kubernetes is going to figure out how to actually manage that workforce. There's also a developer-friendly API, which is a REST API. So what that means is that we can program to this. Now, the other thing that's going to be big is it's a common native API, a common cloud API. So if you think about it, the cloud's been big, but the problem has been we've had specific clouds we've had to work with. There's AWS is really popular now. There's now Google Container Engine. There's the Azure Container Service, and then there's a bunch of them. This hides the implementation like cloud. So if you think about it from CloudBees' point of view, as we're running our application, we have a common API that can be used on any cloud service and on premises. You can think of this almost as like a cloud OS, or from a lot of people may have heard of it, POSIX for the cloud. So there's a common API I can write my code to. And because we have those two features, we're getting developer or DevOps best practices, which then means we can now do immutable infrastructure. We can do infrastructure as code. And so we can actually create our clusters that are easily reproduced and portable. So it means I can create a cluster that can be the same one that I have in testing, that I can in staging, that I can have actually in production. I can have a multi-cloud environment so that I can have a development environment locally on-premise, which might be my development testing one for my developers, and then have production, have it running out in the cloud. So that's why we care about it. And you can see that's why it's helpful for CloudBees and why it's helpful for our customers. So now we know what it is, why we care about it. Let's do a quick dive into the architecture. So there are nodes within Kubernetes, two of them. There's the master node, the worker node. Now, on the master node, you have what are called the Kubernetes cluster services. There's the API service. There's etcd, which is a name value paired database, which will store our metadata for our cluster. There's the schedule that will schedule our work. And then there's a control manager, which then manages the workers, working in conjunction with the scheduler. Now, for our workers to do anything, we want to manage containers, so we have to have a container engine, and that'll be Docker for most cases. It can be other things, but we're only going to worry about it being Docker today. Our control manager has to talk to those workers and have the workers do work for it with that container engine. And that's the purpose of the kubelet. We're going to want to be able to expose some of those containers out to the cluster to work with them. So we have a proxy, which is our service proxy. Now, we're going to have multiple workers, and each worker will have those same 3 things on all of them. Now, as I mentioned, this is going to be a declarative process. And then what we think about is that Kubernetes wants to think about declarative state management. What that means is I'm going to declare the state I want my system to be, and then it's going to implement it. So for example, if I have a deployment with 2 pods, I'm going to have a container image, and then I have a number of instances or replicas that I want for that pod. So you can see here, I've got pod 1 and pod 2. I have a container image, and then I'm going to have 3 replicas for pod 1, and then I'm going to have 2 replicas for pod 2. I'm going to use a tool to take that YAML file and send it to the API service. The tool we'll be using and talking about is kubecontrol, or some people will call it kubectl. I will send the system the commands to take this YAML to the API service. The API service will then talk to the scheduler in the control manager, and then based on that, they will then reach out to each of the workers to then deploy what I've asked for it. So it will now send out pod 1, replica 1, pod 1, replica 2, pod 1, replica 3, pod 2, replica 1, and then finally on the 3rd worker we'll put pod 2, replica 2. So we now have a state there, but this is helpful, but what happens if something goes wrong? Because let's face it, computers, things go wrong. So let's imagine that worker 2 goes away. Now, what's going to happen is Kubernetes is going to say, hey, I do not match the state that I'm supposed to, so it's going to create a new pod and replica for us. And it'll look like to us that this has moved to a new worker, and we will not have to do anything about this. So you can see what the advantage is now from a development point of view. I don't have to write any code. I don't have to do anything with like Ansible or Puppet or Chef to make sure that my application is in the proper state. Okay, so that's basically a high level. So now let's do a demo on the environment to kind of show the low level of how this would work.